Let's start with the simplest question, the one that sounds almost childish, and that's usually how you know it's dangerous. When you put two magnets on a table and feel them pull toward each other, what's between them? Most people answer instantly, nothing. Air, empty space. And yet, something is clearly happening there, something strong enough to move solid metal. That contradiction is not a detail. It's the heart of the confusion. Richard Feynman loved to attack questions like this because they expose how deeply we trust our intuition, even when it's wrong. We are trained from childhood to believe that if something has an effect, there must be a thing doing the pushing. A hand pushes a door, a stick pushes a rock, because touch is effect. So when magnets act across space, our mind panics slightly and fills the gap with the word nothing, as if that explains anything. But nothing is not an explanation. It's an admission of ignorance dressed up as confidence. The uncomfortable truth is that empty space is not empty in the way we imagine. Between the magnets is not a void waiting passively for something to happen. It's an active participant. Physics doesn't say the magnets reach across emptiness like ghostly fingers. It says the space itself has a condition, a structure, that changes when magnets are present. That structure is what we call a field. Now here's the psychological twist. The moment we hear the word field, many people relax, as if a mystery has been solved. But if you stop too soon, you've just replaced one label with another. Feynman was very clear about this. Calling it a field doesn't explain why it behaves that way. It explains how we describe what's happening. And that's enough. This is where human intuition often rebels. We want a picture. Gears, springs, tiny hooks pulling through space. But nature does not care what pictures we prefer. It behaves the way it behaves. The field is not a metaphor. It's the most honest description we have of reality acting where no matter exists. What's between the magnets is not emptiness. It's influence. That idea alone collapses a huge part of how we think about the world. It tells us that reality is not just made of things, but of relationships. Space is not a passive backdrop where events happen as part of the event. Change the objects, and space changes too. That's deeply unsettling if you're used to thinking of the universe as a collection of solid pieces moving around in an empty box, and yet, once you accept it, something clicks, because suddenly magnetism isn't strange. It's consistent. Gravity works the same way. Light works the same way. Even your own thoughts rely on fields and forces operating where you can't see them. The universe is not built from contact alone. It's built from patterns that extend beyond objects. Feynman didn't try to make this comfortable. He didn't soften it with false certainty. He simply said, this is how nature behaves, whether we like it or not. And the job of understanding is not to force reality into familiar shapes, but to adjust our thinking until it fits what experiments actually show. That's a powerful lesson far beyond magnets, because in life we often dismiss what we can't see. We call it nothing because it doesn't fit our expectations. But influence doesn't require visibility. Structure doesn't require substance. Some of the most powerful forces shaping outcomes operate in spaces we're tempted to ignore. Between the magnets, there is no emptiness, only reality behaving in a way that refuses to flatter human intuition. And the moment you stop asking space to be nothing, you start seeing how much of the world you've been walking through without noticing what's really there. Once you accept that there is something real between the magnets, that space itself carries influence, the next idea hits even harder. Nothing is actually touching anything. That sounds absurd at first, because touch feels like the most obvious fact of life. You press your hand on a table, and there it is, contact. Simple. Except physics quietly tells a very different story. Richard Feynman loved pointing this out because it exposes just how unreliable intuition can be. When you touch the table, no atoms ever meet. Not once. What you experience as solidity is the electromagnetic repulsion between the electrons in your hand and the electrons in the table. The table pushes back before contact ever happens. Touch, in the deepest sense, is force without contact. So when magnets repel or attract across space, they are not doing something exotic. They are doing the same thing your hand does to the table, just without the comforting illusion of physical closeness. This is where mechanical intuition collapses. We are wired to believe that causes must push, pull, collide, that force must travel through matter like a baton being handed off. But magnetism refuses to cooperate with that story. There are no gears turning in the air, no invisible ropes snapping tight. There is only space responding to the presence of the magnets. And that makes people uncomfortable, because once you admit that forces don't need contact, you lose the last anchor tying cause and effect to physical touch. The universe stops behaving like a machine and starts behaving like a system of relationships. Things affect each other not by bumping, but by existing in the same structured reality. Feynman didn't try to soften this by inventing new metaphors. In fact, he warned against them. He knew that the moment you say, imagine little arrows pushing through space, people stop listening to the physics and start believing the picture. But magnetism doesn't work because of arrows. It works because the laws of nature say that space has properties. And those properties determine how objects move. The discomfort here is psychological as much as scientific. We want certainty to feel tangible. We trust what we can visualize. Magnetism asks us to trust consistency instead. It says, you don't need to see the mechanism for it to be real. You only need to observe that it behaves the same way every time. That's a brutal lesson for the human mind. It forces you to separate understanding from imagination. You can understand magnetism well enough to predict it, measure it, use it, without ever forming a satisfying mental picture. And that feels like a loss, until you realize it's actually an upgrade. You're no longer limited by the metaphors your brain finds comfortable. This idea ripples outward. Gravity works the same way, so does light. So do electric forces inside your own nervous system. Reality is not built on contact. It's built on interaction. And interaction doesn't require touch. It requires structure. Once you see this, the phrase action at a distance stops sounding mystical and starts sounding precise. There is no action without something mediating it. That something just isn't a material object. It's the condition of space itself. And here's the philosophical sting. If force doesn't require contact, then absence is not the same as nothingness. Space is not a gap. It's a participant. Ignoring it doesn't make it passive. It just makes you blind to what's actually doing the work. Feynman's deeper point wasn't about magnets at all. It was about intellectual honesty, about admitting when the universe doesn't match our instincts, and choosing to follow evidence instead of comfort. The demand that everything be mechanical, touchable, and visual is not a scientific requirement. It's a psychological habit. Magnetism breaks that habit. It shows you that reality doesn't owe you intuition. It owes you consistency. And once you accept that, you stop asking the universe to explain itself in human terms and start learning how to think in its terms instead. Because the real leap forward isn't understanding how magnets pull without touching. It's realizing how much of your certainty comes from assumptions that were never tested and having the courage to let them go by. By now, the word field has probably started to feel familiar, maybe even comfortable, and that's exactly where another misconception sneaks in. Many people quietly downgrade fields into something unreal. Useful drawings, imaginary lines, mathematical conveniences. Helpful for calculations, sure, but not really there. And this is precisely the mistake that Richard Feynman pushed back against, because fields are not bookkeeping tricks. They are where the physics actually lives. Think carefully about what's doing the work when magnets attract or repel. It's not the metal alone. You can remove one magnet, and the other still alters the space around it. Bring a second magnet later, and it responds to something that was already present. That something isn't a guess, it's measurable. It stores energy. It can transfer momentum. It can exert pressure. Those are not the properties of imagination. The field is real because it can do real things. This is where intuition misfires again. We're used to thinking that reality must be solid to be physical. If you can't hold it, bottle it, or point to it directly, you hesitate to grant it full status. But physics doesn't care what feels solid to human hands. It cares what carries energy and influences motion. By that standard, fields are as real as atoms, arguably more so because atoms themselves are defined by fields. Feynman emphasized this not to sound clever, but to be precise. When energy flows through space, it doesn't teleport. It moves through the field. When magnets pull together, the energy isn't stored secretly inside them like tension in a spring. It's stored in the space between them. Remove the magnets and the energy redistributes. That's not metaphor. That's accounting. This forces a subtle but profound shift in how you think about causality. Effects don't always originate where outcomes appear. The motion you observe in matter is often just the visible endpoint of processes happening invisibly in space. If you ignore fields, you misunderstand where change actually comes from. Psychologically, this is uncomfortable because it undermines object-centered thinking. We like to blame things on things. This object caused that object to move. But fields blur those boundaries. The cause is distributed. It exists everywhere the field exists. Responsibility, in a physical sense, is shared across space. And that idea scales. Electromagnetic fields govern chemistry. Chemistry governs biology. Biology governs thought. The chain of cause and effect runs through layers that are not directly visible, but absolutely decisive. Dismissing fields as just math is like dismissing thoughts as just neurons, true at one level and completely missing the point. Feynman resisted the temptation to give comforting pictures because pictures can lie. Lines of force drawn in textbooks are not strings or tubes, they're indicators. The field itself doesn't look like anything, it behaves. And behavior, repeated and reliable, is what science takes seriously. There's a quiet maturity in accepting that. It means you don't demand reality perform for your imagination. You let it speak in its own language, patterns, equations, predictions that work. And once you make peace with that, something interesting happens. The world doesn't become colder or more abstract. It becomes richer. You start noticing how much of what matters is invisible but structured. How outcomes depend on environments, not just objects. How influence can exist without presence. Fields teach you to respect what you cannot see but must account for. This isn't about believing in ghosts or mysteries. It's about recognizing that really, thank you is not obligated to be tangible. It only has to be consistent. And fields pass that test perfectly. So the next time you're tempted to dismiss something because it isn't solid or obvious, remember this, the most powerful forces shaping motion, matter, and meaning don't announce themselves as objects. They operate quietly, everywhere at once, and once you learn to take them seriously, you stop mistaking invisibility for insignificance. At this stage, a familiar frustration usually surfaces. If fields are real, if space has structure, if magnetism works with perfect consistency, then the question people want to ask is obvious. Why does it work this way? Why does a magnet create a field at all? Why should space behave differently just because a piece of metal is nearby? And this is exactly where Richard Feynman would stop you. Not because the question is stupid, but because it's dangerous. Feynman was famously resistant to answering why questions about magnetism, and many people misunderstood him because of that. They thought he was being evasive or arrogant, or that physics simply didn't know enough yet. But that wasn't the point. The point was that the question itself often hides a false demand. When we ask why in everyday life, we usually mean what caused this, or what purpose does this serve. But in fundamental physics, those meanings collapse. There is no deeper mechanical cause underneath magnetism that we can point to the way we point to gears inside a clock. Magnetism is not a consequence of something simpler. It's one of the rules. And that's a hard pill to swallow. The human mind wants a bottom layer where everything suddenly makes intuitive sense. We want the universe to eventually explain itself in terms that feel familiar. But Feynman's insight was brutally honest. Explanations don't go on forever. At some point, you reach a description that is simply how nature behaves. Not because we're lazy, not because we've given up, but because explanation has a stopping point. Magnetism is one of those stopping points. You can describe it, measure it, predict it, use it to build motors, computers, entire civilizations. But asking why magnetism exists is like asking why the universe has rules at all. You're no longer doing physics, you're doing metaphysics and pretending it's science. This matters psychologically because it exposes a deep discomfort we have with foundations. We want certainty wrapped in narrative. We want causes to have causes, and those causes to have intentions. But nature does not negotiate with our storytelling instincts. It offers patterns, not purpose. Feynman wasn't saying curiosity should stop. He was saying curiosity should be honest about what kind of answer it's asking for. If you want a deeper theory, fine, go look for one. Physics has done that many times. But don't confuse dissatisfaction with current explanations for evidence that they're incomplete in principle. Sometimes the universe ends words with silence, not because it's empty, but because the question was aimed at the wrong target. And there's something profoundly clarifying about accepting that. It forces a distinction between understanding and comfort. You can understand magnetism without feeling emotionally satisfied by it. You can know how something works without liking the fact that it has no deeper reason. That's not a failure of science. That's a boundary of human expectation. In fact, insisting on why can block understanding. It can make you dismiss real knowledge because it doesn't come packaged the way you hoped. Feynman's refusal was a teaching tool. He was saying, don't mistake your hunger for meaning for a flaw in reality. This insight extends far beyond physics. In life, we often demand explanations that reality is not obligated to give. Why did this happen to me? Why is the world this way? Sometimes there is a cause you can trace. Sometimes there isn't one that satisfies emotionally. But the absence of a comforting answer doesn't mean the system is broken. It means you've reached bedrock. Magnetism teaches humility. It shows that the deepest layers of reality are not designed to make sense to us. They are designed to be consistent with themselves. And consistency is enough to build knowledge, power, and progress. So the reflection to carry forward is this. Stop demanding that the universe explain itself in human language. Learn its rules. Respect where explanation ends. And use understanding not as a source of comfort, but as a foundation for clarity, action, and intellectual courage. Once you've accepted that magnetism doesn't owe you a deeper why, another realization settles in, and this one can feel unsettling if you're not prepared for it. Magnetism is not strange because it's complicated. It's strange because it exposes the limits of how the human mind expects the world to make sense. Richard Feynman understood this better than most. He didn't see magnetism as a puzzle to be solved once and for all, but as a reminder that the universe is under no obligation to match our intuitions. Our brains evolved to throw rocks, recognize faces, and survive long enough to reproduce, not to understand fields acting across empty space. Expecting reality to align with intuition is like expecting the ocean to behave like a bathtub. Magnetism doesn't just challenge what we know, it challenges how we know. We like explanations that feel mechanical because they give us psychological comfort. Levers, pushes, collisions, these ideas feel controllable. They let us imagine that if we could just see more closely, everything would eventually click into something familiar. Magnetism refuses that promise. No matter how closely you look, you don't find tiny hooks or gears. You find equations that work and intuition that lags behind. This gap is not a failure of intelligence. It's a feature of being human. Feynman often emphasized that understanding in science doesn't mean visualizing everything. It means being able to predict outcomes reliably. If you can calculate what will happen, and it happens every time, you understand the phenomenon, even if your brain never gets a satisfying picture. That idea is deeply counterintuitive because we confuse familiarity with truth. Magnetism teaches a hard lesson. Reality doesn't need to feel reasonable to be real. There's a psychological resistance here worth noticing. When something defies intuition, people often react in one of two ways. They either reject it outright, calling it nonsense, or they try to force it into a metaphor that feels safer. Both responses are attempts to protect the ego. They avoid the discomfort of admitting, my instincts are not a reliable guide to the deep structure of the world. But intellectual growth begins exactly at that admission. Magnetism becomes a mirror. It reflects back the boundaries of human cognition. It shows that our sense of obvious is shaped by scale and experience, not by truth. At human scales, contact matters. At atomic and cosmic scales, fields dominate. The universe is not weird. It's just operating outside the range our intuitions were designed for. And here's the liberating part. Once you accept those limits, you stop fighting reality. You stop demanding that knowledge feel intuitive before you respect it. You learn to trust consistency over comfort. That shift doesn't weaken understanding, it sharpens it. This mindset extends far beyond physics. In economics, psychology, relationships, even personal growth, we often reject truths that don't feel right even when evidence keeps pointing in the same direction. We cling to intuition because it feels like control. But magnetism reminds us that control comes from alignment, not denial. Feynman never pretended that this was easy. He embraced the discomfort. He treated confusion not as a flaw, but as a signal that something deep was happening. When intuition fails, it's often because you're standing at the edge of a more powerful way of thinking. Magnetism doesn't mock human understanding, it humbles it. And humility is not weakness, it's the doorway to learning things that intuition alone could never reach. So if magnetism feels unsettling, that's not a problem to be fixed. It's an invitation to let go of the need for everything to make immediate sense and to replace it with a deeper trust in patterns, evidence, and consistency. Because the moment you stop demanding that reality feel intuitive is the moment you start understanding it on its own terms. And that's where real intellectual freedom begins. By the time you arrive here, something subtle has already shifted. Magnetism no longer feels like a trick or a puzzle waiting for a clever picture to solve it. Instead, it feels like a boundary, one that separates what we want reality to be from what it actually is. And this final step is the hardest, learning to live with meaning, even when there is no mechanical story underneath. Richard Feynman was deeply uncomfortable with fake explanations, not because he disliked clarity, but because he respected reality too much to dress it up in metaphors that didn't earn their keep. When people demanded a mechanism for magnetism, little hooks, tiny springs, invisible messengers, he refused, not out of stubbornness, but out of honesty. Those pictures don't exist, and pretending they do doesn't deepen understanding, it replaces it with illusion. Here's the uncomfortable truth: you can understand something without being able to visualize it. That statement cuts against almost everything we're taught. From childhood, understanding is equated with imagery. Can you picture it? Becomes the test. But magnetism exposes the flaw in that rule. You can predict it, you can measure it, you can build technologies that depend on it with astonishing precision, and yet there is no final mechanical picture waiting at the bottom. And that doesn't make magnetism weak. It makes it fundamental. This is where meaning quietly re-enters, not as a story about causes, but as a discipline of respect. Meaning doesn't come from forcing nature to explain itself in human terms. It comes from aligning your thinking with how nature actually behaves. You don't need a metaphor to trust consistency. You don't need a picture to act intelligently. Feynman's deeper lesson was never stop asking questions. It was ask questions that reality can answer. When you stop demanding comfort and start demanding coherence, understanding becomes sharper, not emptier. You stop confusing satisfaction with truth. And psychologically, this matters more than we like to admit. Much of our frustration with the world comes from expecting it to operate like a story, with motives, intentions, and resolutions that feel right. Magnetism offers none of that. It simply is. It behaves according to rules that don't care whether we find them elegant or ugly. But that indifference is not cold. It's stable. Once you accept that, something powerful happens. You stop fighting the limits of explanation and start working within them. You stop asking, why must it be this way? And start asking, given that it is this way, what can I do with it? That shift from protest to partnership is the essence of scientific thinking, and it's useful far beyond physics. In life, many forces shaping outcomes are not visible, not intuitive, and not negotiable. Trying to force them into comforting narratives wastes energy. Learning their rules, honestly, without decoration, gives you leverage. Magnetism teaches that clarity doesn't require a story. It requires consistency, evidence, and humility. Feynman never tried to make the universe emotionally satisfying. He tried to make it intelligible. And intelligibility is enough. It allows you to build, to predict, to navigate reality without lying to yourself about how it works. So the final insight is not about magnets at all. It's about maturity, about learning to respect reality without demanding that it explain itself in ways that flatter human intuition, about finding meaning not in metaphors, but in alignment with truth. Because when you stop forcing the universe to make sense on your terms and start learning how it actually behaves, you don't lose meaning. You gain the power to think clearly and to act wisely in a world that was never designed to be simple.